Welcome to the Rossman Group Cat Cam. This is a live feed of Barry, little Blackberry, taking up somebody's seat at Rossman Repair Group. Isn't she cute? Oh, look at that yawn. Oh, she has important things to do. So do we. You replaced a scene.
No, you just gotta.
Thank you. Hi, everybody. It's Paul from Rossman Repair Group today. Today I have a A1708 MacBook Pro. This is the 2016 model, the one with the 2 USB-C ports, and its description is no power. We didn't get any other liquid damage or anything like that, just no power. So let's take a look at the board here. So first thing I'm going to do, let's plug it in, let's see what it's taking. Plug in our USB-C amp meter to our USB-C charger. There's a regular Apple USB-C charger on the other side of this. It needs to be 85 watt or bigger to actually get things to work for you. I think we have the 96 watts everywhere here. So now we have 5 volts. So it's taking 5 volts and taking no amperage whatsoever. So we'll check the other one. Same thing, 5 volts, no amperage. Now we'll flip the charger over and check the other way too. 5 volts, 0 amps. And the other one again on the other direction. 5 volts, 0 amps. So now this is indicating to me that there's a problem not in the power acceptance area, the CDs. It could be something shorted in here, but it's not something specific to one chip. It's something that's affecting everything here. So we need to take a look at the stuff that affects everything here. So things that affect everything here, there's 2 main power rails that have to turn on before anything else works. That's PP3V3 and PP-Bus G3 Hot. PP3V3 is more important for these guys than PP-Bus because PP3V3 is what powers these chips to be able to communicate with the charger. So since there's no communication, we have no 20 volts, so it's not talking to the charger to tell it, hey, give me 20 volts. I'm leaning towards something wrong with PP3V3. So it's these caps up over here, so let's look at that under the microscope so you can see it a little closer. So these 2 big caps right here, one of them on each one of them is PP3V3 G3 Hot, the power rail we're concerned with, and the other one is a 3v3 line that the CD creates itself. So let's take a look at, let's just measure them. Get the multimeter on the screen, wrong one. Multimeter. So right now I don't care which one's which, I'm just going to measure all of them and see if anything is shorted. So check this. 5 million ohms. No, that's not shorted. Check this one. Open line. That's not shorted. And this should be the same one. Okay, 1.4 ohms. That's shorted. These probes are kind of dirty. Let me clean up my probes. Okay, if this one's shorted, then the other one should have been shorted. 1.4 ohms. So that's PP3V3. So this should be PP3V3 as well. 1.4 ohms. Yeah, there was a piece of dirt on my probes that kept me from testing that. Okay, so PP3V3 G3 Hot is shorted. So let's take a look at the schematic. We'll move over to the schematic and board view. And now we're looking for PP3V3. So I already know where I'm working at here. So we're working on these guys here. These are the CD3215s. And we were looking at this here. So that's ground. Here's PP3V3 G3 Hot. So it's named a different name now. It's PP3V3 G3 Hot UPC-XA. And this is UPC-XB. So this is just the power that's running the CD3215s, and you can see where PP3V3 G3 hot comes into the whole thing through this one little resistor right here, right next to this. On the both sides, they're mirrors of each other. They look exactly the same. So this is what we're looking at here. This is PP3V3 G3 hot is shorted to ground, 1 ohm short to ground. So now I need to find out where this is created. We want to look at the creation area. Actually, it doesn't really matter at this point. We're just going to take a look at the entire board, visual inspection. That's the key to really fixing a lot of this stuff, is a good visual inspection of everywhere where PP3V3 G3 hot goes to. So I'm just going to take a look over all of this stuff. We're going to look at everything that PP3V3 G3 hot goes to. So it's not that much. It's spread around on the board, but let's take a look at it. So bring it back to the microscope. We already saw the CD3215s. Everything looks good here. There's no corrosion anywhere. There's no green stuff growing on a capacitor. Capacitors themselves, they short out, and usually they crack when they short out. So the best way to see a shorted capacitor is to look down the side of it. See if I get this in focus. You look on the side of it, and you'll see that there's if it's shorted, there'll be a discolored crack running along the side of it. And you got to look between resistors. Capacitors. This helps a lot when you have a bad backlight, because these backlight capacitors up here, one of them likes to short out all the time, and if you look right down the side of them, you'll see, usually up against the side edge or something like that, like right in there, there'll be a little white crack, and you'll see a different color variations along the side of it, and that helps you identify the shorted, broken capacitor. Usually when these guys short, they almost always crack. Let's take a look through here. So PP3V3 goes here, nothing there. PP3V3 is on the sleep sensor right here. And I don't see anything weird about the sleep sensor. It's an awfully clean machine. There's barely any dust in here or anything. Usually the stuff gets full of dust and dirt. This machine's well taken care of. Okay, so that I think that covers that side. Let's go back to the schematic and board view. Yeah, so we looked at this. We looked at these. Everything looks fine there. The other side of the board, just a couple. This is a no stuff. If I actually bring it up on the schematic here, you'll see that it's omitted, or no stuff. Yeah, these development LEDs. All of this stuff was left out of the finished product, so that we don't even have to really look at that, because that's no stuff. But it's good to look at, just in case there is some corrosion on it, some random water landed on that. But no, there's nothing wrong with that. So you see there's just blank pads. There's nothing actually there. That was only used for developing. They put LEDs across this to indicate things to themselves. Okay, so we looked at that. Let's go to the other end of the board. So we have a bunch of stuff up over here. So I'm on the side with the CPU now. And there's a bunch of little things all up in here. So let's just go look in that corner there. And that's all this complicated zone right here. A bunch of stuff here. Now I'm looking for something that has like white or green hairy stuff growing off of it. Don't see anything here. Everything's nice and clean. Okay, so let's flip the board over to the other side. If I zoom out here, we'll look at the other side. Right underneath where we're at, there's a lot of stuff that uses PP3V3. So let's take a look at that. So everything looks fine here. Nothing going to... Uh-oh. Everything fine there. Uh-oh. That doesn't look good. That definitely doesn't look good. So usually these things, you look at this and it's not easy to scratch these chips. This is just falling apart because this is carbon now. This isn't the original chip. This has been burnt up. So we have a giant hole in our SMC. Wah, wah, wah. Okay, so we look at the schematic and board view. We see that the SMC here has a lot of PP3V3. So that's what runs the SMC, is PP3V3. So let's see if taking this off of here, if the problem with this a lot of times is when this goes bad, because it has so much going to it, because it's taking so much 3v3, so many pins there, it usually damages the board with it too. So let's take this off. Let's make sure the board is not damaged. If the board's not damaged, then this may actually survive. This might be just fine. And unfortunately, this is no fault of the owners or anything like that. This thing just exploded. This MacBook, this board is extremely clean. So turn on my fume extractor. This is gonna get a little smoky. Move it a little closer to me. Take my hot air at full and full. For me, it's always full and full, so it's 500 degrees at 120 liters of air. I never adjust my hot air for anything, pretty much. It's maybe once a week I might change the temperature. That's about it. Circle around the chip you're working on, heat up the whole board around it. You don't want to thermal shock just the little area that you're working on. And I see it moving, I could lift it off. Okay, that looks okay. It doesn't look like there's any hole in the board underneath that. This should work out. Now, we don't know exactly why this SMC has exploded, so that could be a problem. So I'm going to come in with my soldering iron and a little bit of fresh leaded solder. So we want to wick all these pads off, and it's easier to wick leaded solder than it is lead-free solder. So we're going to suck up all the lead-free balls off of there. Now we just have a little bit of leaded solder on here, so then we'll come in with some goot wick. Just clean this all off. Want everything to be nice and flat for when we get the chip ready to go back on here. Okay, we've got a Q-tip. Clean this off. Okay, the patient board is prepared. Now we need to find an SMC. So we're going to go to a bin of donors. Got my bin of donors for this A1708 board. And let's just flip through a couple here, and we're going to find one that has, looks like the SMC is not destroyed on it. So this one is a contender. This one, these are the ones that I like to see the most, is that they have a giant hole drilled through the board. The other chips have been removed off of them. So this was one that we bought from China, and it was thrown away. They drill a hole through the board so it can't be used as a board ever again. And then they take the chips that are of most value to them, the CPU, the RAM, and then they sell us the rest of the carcass. So this SMC, should be good. Uncover it here. It's a little beat up. Even if they, even with the tape covering it, it looks like it got a little beat up in the process of getting thrown away. Maybe I might use that one, but I like this one. Somebody used the PMIC off of this. Presumably this should be a pretty good board. This probably has a dead CPU or something. Yeah, it has this this MOSFET missing. This area is a common liquid damage area on this, and if it gets liquid damage, it kills the CPU. So that's probably what happened to this one. So I like the look of this one. I'm gonna take this one. I'll keep that one to the side. Might want to use that. Using leaded solders for noobs, pros use lead-free. You have no idea how to work on electronics. You have never once picked up a soldering iron. You have absolutely no idea what you're talking about. That's fine. So, a little bit of flux. We're going to do the same thing that we did with the other one. Heat around the whole area. This one I don't care so much about the board or anything. All I want is the chip off of it. So, but I'm still going to heat all around the chip and then come in and heat the chip. Okay, our chip is off. Now I'm going to place it into a reballing frame. Get it into the little groove on the arms here. Close it up. Now I want to clean this off. I don't have to clean it off as much as I did the board. It's not completely flat in there. It looks like there's dirt in my grooves. Okay, that looks good. So now we just want a good even surface to work with here. So we're not worried about this one being flat or anything, but we just want a good even surface. So I'm going to take my soldering iron. I'm just going to take a nice bubble of solder and just drag it across it. Try to get all the pads new and shiny. And about the same size. That looks good. I'll take a Q-tip, clean that off. You don't want anything on the chip before you start reballing it. All this excess flux will mess things up. So you want to just pull everything off of it. Nice and clean. Okay. Nice and clean, it's dry. No flux on it. And we place our stencil. Now, you see that there's one missing. There's one ball missing there. That indicates where pin 1, same with that little flag there, that indicates where pin 1 is. So when we put the stencil down, we need to make sure that the empty space goes where that pin 1 is. Then captain tape. I need to find the captain tape here. Now we'll just tape the stencil down over top of it. Mario, thanks for doing board repair streams. You're welcome. Thanks for tuning in. Hope you enjoy it. Hope you learned something about it. Okay, I have my captain tape. I have some tweezers to cut it. Now, I'm going to ruin the alignment a little bit. Always putting the first one down. Yeah, that's not bad. But then we'll fix it. Make sure, by the time you put the second one on, you have to make sure the alignment is perfect. Okay, I tried to get it only on the stencil, so now I can move the stencil around a little bit. Get it aligned just right. Make sure everything's good and adhered. And then I'll put 2 more there, too. You don't want the stencil moving on you while you're heating it up. Okay. So now I'm going to take my lead-free solder paste here. I'm going to squeeze out a little bit. Just a little dollop out of here. Ooh, this one doesn't feel like it's any good anymore. Or no, there's just a lot of flux that has built up inside here on the rubber, so it does not want to slide. There we go. That should be about enough. I'm going to put it on the back of my tweezers. And then we're going to spread it onto the stencil. So I go over it a couple times. You see me go over the same spot a couple times. And I'm looking for any holes here that are just going to open up to nothing actually being in them. Multiple directions. Make sure all the holes are filled. That looks good. Now I'll clean off my tweezers. You have to be really careful with solder paste. Anybody that's out there, if you start soldering with solder paste, be very careful with it. Be very clean with it. Everything gets cleaned up immediately. You clean the back of your tweezers. You clean your workspace with it. Don't ever let this stuff just mill about. This is actually tiny balls of lead. If we zoom in, you could actually see that they are tiny balls of lead that's suspended in flux. So you don't want this stuff hanging around on your hands. When you're done doing a job like this, go wash your hands right away. You don't want to touch your eyes with this stuff. You don't want to eat your lunch with this stuff on your hands or anything like that. Northwide Service. I'm listening to you making wire looms, making sure to leave the cut ends of the wire extra long. Awesome. I've only made wire looms for vehicles before. It's fun. It's a relaxing job when you, especially if you have like a loom board and you're just running wires around pegs and then terminating them with connectors. It's so relaxing. I used to do that at I used to work for Lucent Technologies, working on telephone switches, and that stuff was fun. So yeah, safety always important when working with leaded stuff. So this, you see that they're just tiny leaded balls, and we're going to melt this up into larger leaded balls. So I'm going to take my hot air again, still full and full, I'm not changing it. I'm going to hold down the stencil, because even though it's taped, we don't want the tape buckling or anything, the adhesive getting weak because it's getting heated. The tape will survive just fine because it's Kapton tape. It's made for high temperature. So we're blowing 500 degrees Celsius air at this pretty forcefully. And now I'm going to come in with the air, and I'm going to point at it. And you're going to see these balls puff up like muffins out of a muffin tray. And that's when I back away from my air. So I don't change my air temperature by the machine. I change it by the distance that I'm at with it. So you see them start puffing up, and then I'm just going to pull away a little bit, and you see a couple start melting. Make sure everything's good and melt it. There you go. Done. So then we'll lift the tape off. And now if you have a good stencil, you see the stencil didn't want to come off right away with the tape. It should have just came right off with the tape. But if you have a good stencil, it's not the leaded balls. It's not the lead, the solder that's holding the stencil on here. It's just the melted flux that's all between the stencil and the chip and all the in-between areas. So we're going to come back in with the hot air. I'm going to get the corner of the tweezers under the corner of the stencil here. Oop, it opened a little bit. Make sure your chip holder has a good hold on the chip. And then I'm just going to, a little bit of heat just to remelt the flux, and it comes right off. See, I didn't melt the balls again or anything. I just melted all that flux. You see all that shiny flux in between there. That's what adheres the stencil on there. I've seen people make the mistake of overheating it, and then when they pop this off, all the balls are melted, and they shoo off half of the balls, moving the stencil. Okay, there's our reballed SMC, all ready to be put back on. So now we'll come back to our board. So now, Apple, this is one of the ones that I like too, because Apple doesn't do silkscreen on their boards. So there's no indication of what this chip is or which direction it's supposed to go on the board, except for, you see we have a missing ball right here. So Apple can't obfuscate this to where we don't know which way it goes on, and the only way to know is to look at the schematic. The schematic will tell us which way it goes. If we go to the board view here, you see pin 1, the red one right here. You see the empty one right here. So even if this was filled here, even if there was a ball here, you know pin 1's here. And then when we look at the chip itself, from both directions, see we have a dot there in the top corner. That's pin 1. And if I flip it over, you see we have the missing pin and a little triangular flag there. That's all indicating pin 1. So now we know pin 1 goes up in there. But they can't really obfuscate this because there's a missing pin, so it leads us to put it on the right direction no matter what, if I had the schematic opened or not. So we'll put a little bit of flux down here. We'll get the Mr. Clinton hair out of the flux. We'll place this down right in the middle. I'm going to push down on it and kind of scrub it around a little bit. And it's only the pads that we're looking at. When you're looking at the pads, the black solder mask that's on the board is a little bit taller than the pad itself. So the pads are little wells underneath there. So when you get it on, when you get the chip, the balls all lined up with the pads and shift it around a little bit, it's only going to move as much as one pad, and that's it. It's not going to hop out. So I know just by this sliding around that we're on the pads and in the center. Other boards from other manufacturers would have white lines on 2 of these, or all 4 of them, little white corner marks to help you make sure that the chip is aligned. But we don't do silk screening with Apple. So now I'm going to hold it down very lightly, and I'm going to start heating it. Now you can't push down on this while it's melting, because you'll just shoot all those balls out the side of it. But I just want the flux to bubble out of the sides. Once all the flux is bubbling out of the sides, then I could stop holding it, because then I know the chip's not going to float away on me. And there you go. I saw it move into place, and I can make it jiggle. The chip will jiggle a little bit, moving the air around, and that should be soldered on there just fine. Okay, we could do a little bit of cleanup with a Q-tip. This corner, the board is so clean that I don't need to ultrasonic this, but with this much work here, I'll dunk this corner in the ultrasonic cleaner and just clean up the work that I did here. It's no clean flux that we use. It's Amtech no clean flux. The no clean means that it will not harm the board if it's left on the board. So other flux, like if you get some flux, some old flux, like I have a tub of Radio Shack flux. I've seen people use plumber's flux on boards before. Please don't ever do that. Don't ever use a tub of plumber's flux on electronics. That is most of the time corrosive. If you go back to, like, speaking specifically of plumber's flux, if you use too much plumber's flux on a pipe and go back later and look at it, you'll see that it turned all green and crusty. You're doing that to everything copper on here when you use plumber's flux. Don't ever use it. I was going to say, like, if you use it, make sure you clean it. No, just don't use it. If you use anything that's not no clean flux, you need to make sure you clean off every little bit of it. This is no clean flux, which means it's not going to harm anything on the board, but it's still not professional to just leave flux all over the board. You should clean up after your work. So this will get dunked in the ultrasonic, just this one little corner of the board. So SMC is replaced. Let's see if we still have a short on PP3v3. So this is the PP3v3 creation area in this little corner here. So I'm just going to go right to the coil that creates it. 10,000 ohms. That looks fine to me. No longer short it. So now let's plug it in and see what it does. Plug in my amp meter, and then plug in the amp meter to the board. 5 volts, we're taking some amperage. Hey, we changed to 20 volts. Still not taking any amperage though. 20 volts, 0 amps. Let's try again. Okay, we have 20 volts, 0 amps. Let's take a look at... We should have 3v3 because we have 20 volts. 3.4, it's a little high, but that's good. Let's check PP bus. $13.06, that's good. So now what else are we missing? $20 volts, 0. Do we have 5 volts? I do not have my 5-volt rail. I have 300 millivolts on my 5-volt rail. So let's see if I have the enable for my 5-volt rail. Let's go back to, I need the schematic and board view for this. So what you do now, like we're missing, we're not doing any, the board is not doing anything here. So what we do is go down this list. I have the list somewhat memorized, so I don't need to go find it every time. But yeah, here's the list. This is like the power rails in order, loose order of how they turn on and how important they are. They don't have, for these machines, they don't have like a nice definitive list of what turns on and when. Some of the other machines do have that. But we see we have PP bus, G3 hot, we have PP bus, PPDCN, we don't have a battery, so we have to have PPDCN to have any of this. PP5V S5, so the LDO is not the one we're looking for. We're looking for the purest form of this power rail, which is PP5V S5. So we look at PP5V S5, this is where I test it for it, right here, on this chip, U7650. So let's open up the schematic for U7650. Now there's three things we need for any power rail. We need the power to create it from. We need a safe line for the power to go down. And then we need an enable for it to be enabled to be created. So we have two enables on this chip here, because this chip is responsible for two power rails. So we have 5V S4 enable and 3v3 S5 enable. Actually, there should be another one. Oh no, it goes to another one. That's what it is. So let's follow this. Pin 4. Where'd my cursor go? My cursor disappeared. Okay. Pin 4. 5ES4 enable. I'm not looking for S4 though. 3v3 S5? Oops. 3v3 S5 enable is on 21. S5 enable. PM enable PVX S5. So this is all the S5 rails that I'm looking for. P5V XX enable. So I'm looking for PP5V S5. So it's the 5-volt rail on the S5 power state. That's what's missing. So we should have all the S5s as soon as we plug it in. So this is missing. So this is the enable for it. PM enable PVX S5. So this should turn on all the S5 rails. So let's measure that on the chip itself. I see there's a piece of MacBook food on that. Get the MacBook food out of here. Okay, it's above the capacitor, and it's this test point right here. 0. So I do not have the enable. So I can't blame this chip for not creating it if it's not being told to create it. So where does that come from? Zoom out. Oops, you're not on the schematic. So we're looking at this, PP5V, or P5V XX enable. Zoom out, see where it's coming from, and that comes from over here. So right next to the PMIC, there's a little chip. Right next to the PMIC, there's a little chip. So let's see what's on this chip. So we're looking at, it is being pulled down to ground, so it's going to be a high value resistor. 47K, and I see this chip is a logic gate. So PMIC enable and SSD power required to give us PM enable PVXS5. It's run by PP33G3 hot. So when you look at any chip on the board, this is a great example. Any chip, this represents that square chip that we're looking at. The power rails that run the chip, that turn the chip on, come in from the top. The grounds are on the bottom. The signals coming into the chip, or powers coming into the chip for it to do its processing or do whatever it needs to do, come in from the left side. And then whatever signal the chip is putting out comes out of the right side. So it needs these. These are coming in. It shows that this one's coming in. This one doesn't really show that it's coming in, but it's running this chip to turn it on. And then this is what's coming out of the chip. That holds true for just about any chip you look at. Whether it be this big one right here, these are the powers that run it, VDD, VDDP, VDDL. These are the powers that run it. These are the signals that are coming into the chip for it to do its processing and stuff. And this is the signals that come out of the chip to do other things on the board. So we need SSD power required, and we need PMIC enable 3v3S5. So 1 and 2 should be high for us to even get this. So high is a logic level high. So it's either 3.3 volts, 5 volts, depending on what we're working on. It could be any one of those on any of these boards. So we're going to go down and look at SSD power required, PMIC enable. Take a look at both of these. So now it's kind of difficult to read something like this on the chip. There is a little bit of a copper pad. Let's see if I could get that in focus. On the side of the chip. So this is called a flat pack with no leads. So there's no leads coming out the side of it, but there are these copper pads that come out the side of it. So I can, if I have sharp enough multimeter probes, which these should work, I can touch those pads there. So the one I don't need to because it's connected to that resistor there, but the one all the way in the corner, pin 1, I do need to try to touch that pad right there. So first let's do the easy one. Okay, I got 0. That's great. And then this one, I don't think I'm touching it. Either that's flickering or I'm not really touching it. Let's see. I pull that away, it's not doing anything. This probe is not small enough to get in there. But this one, already we see it's an issue. What we can do, click on that, the one we're trying to get to. So if I look at the schematic and board view, this is the one I'm trying to get to, and my probe here isn't sharp enough to be able to touch that pad on the side. So let's click on it. Oh, look, there's a test point for it right there. You can go right to the test point. So this is the test point that connects to there. Connect to that. I have neither one of these. So I'm supposed to have both of these, and I have neither one of them. And let's see where they're coming from. Okay, that one's just coming from the SSD, or near the SSD. SSD power required. PMIC enable. Okay, this should, yeah. PMIC power good. This is coming from the PMIC. So we can't blame this chip because, again, it doesn't have its inputs, either one of its inputs. It could be either or of these. We'll turn this on. So this looks like we may have a bad PMIC, or the PMIC is not being powered. So this is the power for the PMIC. This one? One of these. All of these? I think so. It needs 3 volts, it needs 5 volts, and it needs PP bus. So let's check these banks of capacitors up here and see if the PMIC is getting its power. here's the banks of capacitors. Check this one. I have 13 volts. Check this one. I have 5 volts. Check this one. I have 3.2 volts. So the PMIC is getting all of its powers, but it's not enabling the S5 rails. So I'm thinking we have a bad PMIC as well. So we had an exploded SMC. Now I think something happened along the line that killed the PMIC as well. So we'll have to take this off too. Okay, this is almost the exact same chip as the SMC on this board. It's the same size, same pattern. PMIC reset. That's a good thing to check for. George, yeah. This is my punishment for not recognize Paul voice in the first time. I don't sound like Lewis, do I? We sound different. And Dan sounds different too. Dan will be up later too. He has another board repair too. Let's check PMIC reset. So we'll go back to our schematic and board view, and I'm going to search for PMIC reset. I think Lewis has Control F? Yes. Why does Lewis's spacebar not work? Oh man, he just changed his keyboard because keys weren't working, and this space bar does not work. Okay, I'll put an underscore. PMIC RSM reset? No. Is power good? No. Which reset do I have? PMIC shutdown? Switch power okay. I don't think there's a discrete reset for PMIC on this board. Is this power okay? No. Maybe this one. Let's see where this comes from. PM reset L. So power management RSM reset. So we can check and make sure that this isn't being held and reset by this. This comes from the CPU. It also goes to the SMC. Oh, good catch on this. I could have put a bad SMC if this is bad. Where can I test it? Okay, I have a test point. I have a resistor. Let's find that test point. So, PMIC, straight down underneath it. It is that one with the faint circle around it. Nope, I don't have it plugged in anymore. If you're going to test for voltages, you have to have voltage. Still 20 volts 0. And we test this. And it is 0. Is this reset when it is low? PM reset, yep. This is reset when it is low. Is this shorted to ground? $57,000 ohms to ground. That's not shorted to ground. What happened to my multimeter? There it is. $57K, so it's not shorted to ground. But it is being reset. So where does this reset come from? This reset comes from probably the CPU. 3v3. That's what's... Okay, so... This is like PM Sleep S4L, where this resistor creates the PM reset, and then something has to pull it down to reset. So we need to make sure that this power rail is working correctly on that resistor. Oh, shit, I'm sorry. So yeah, this is what I'm looking at. So this is the PM reset that we're looking for. And this is the rail that creates that PM reset. So naturally, this PM reset wants to be 3.3 volts because it just goes through this resistor. And then something that you see green here is going to pull that down to 0. So let's find this resistor. Where is it? It might be underneath the... No, it's right in front of the heatsink here. Okay, it is the two middle ones are what we're looking at. And the power rail, I'm looking to see if it's working, is on top of this one. Oops, I'm on ohms. This one here. That power rail's not even turning on. Okay, so we can't blame the reset because that power rail's not even turning on. So this brings me back to thinking that the PMIC is bad. So we'll just change this PMIC. So same thing as before. My hot air is at full and full. I'm just going to heat all around the chip that I'm working on. Everything seems nice and hot. I'll just come in right on the chip. Once I see it dance a little bit, I'll pick it up off the board. Okay, now we'll replace the lead-free with leaded solder. Come back with some wick and flatten out all those pads. There's a lot more components really close to this chip, so you want to try to not to suck off the solder off the components. When you're done wicking, you want to inspect all the components around it. Make sure you didn't take all the solder off of one side of them. So we'll clean it up so we can see everything. See, I did take some solder off of that one capacitor, so I'll have to come back and put some solder on that. All the pads look good. We'll just add some solder to that capacitor. And I made a mess of it. Let's add a little bit of flux to it. And it's still shorted. I don't know if you can see the bridge that's there. These things are really, really close together here. So now I'll have to wick it again Wow, that really does not want to let go. There you go. Okay. A little bit of solder on this. Just add some more. That looks good. Okay, clean that up again. And now we're going to go diving in our donor boards for a PMIC. So we'll put our patient board to the side. How's the... Oh, the donor board that I use doesn't have a PMIC. So let's grab another one. This one looks good. Okay, same thing. A little bit of flux. We'll take this off the board. Now we'll take our reballing frame again. We need to clean it up. We'll make a new one of them. I'll just take this solder off with some fresh leaded solder. Make a nice ball on the end of our soldering iron. Just float that ball right on top of everything. Make sure everything's nice and shiny. So now we have one dull pad there that's not taking any solder. I want to get in there and touch that directly. Okay, I might have to get a... let me get some flux on there, and I might have to get a micro tip. There's no micro handle on this station. There we go. Okay. There's a blemish on here. Is that just... Yeah, that was just some dried flux. I thought there was a hole in it for a second. a little better look for you. Okay. Got our stencil. Line up the missing ball. So I picked this one because I thought it was going to be a nice, easy one to work on. So we changed an SMC already, and now we're changing the PMIC. And I don't know if this is going to work after this. But such is life of repairing. Okay, it's adhered down nicely. Now we'll take our solder paste. Small blob on my tweezers. And we'll fill in everything here. Go over it in multiple directions, a couple times. Make sure everything got full. You don't want to press it down into it, or else it'll start smushing around on the bottom. That should work. Immediately clean off my tweezers. And I'll clean this off. Very lightly with a paper towel, just clean off the top. Okay, hold down the stencil, and we'll start heating it at a distance. Slowly come in a little closer. Oop, and I was quick enough to get the stencil off with the flux still melted. Clean off my stencil while it's still warm. Alright, clean stencil, reballed chip. Now we can put this one on. Okay, we look for where pin 1 is. Make sure we line up pin 1. Add a little bit of flux. Line up pin 1 with pin 1. Push the chip down into the flux. Scrub it around a little bit. Feels like it's in the spot. Now we'll heat it in. As soon as the flux starts bubbling out, I know the chip's not going to swim away on me, so I can stop holding it. You don't want to be holding it when the balls underneath melt. That looks good. Let's give it a little jiggle. Yep, that looks good. A little bit of Q-tipping around it. And we'll rapid cool it. Oop. Put it in my fume extractor. Let it rapid cool. Okay, is it touchable? That's cool to the touch. We can try this again. Okay, we'll take our amp meter, plug it in, and what do we get? 20 volts, 40 milliamps, 0. Five volts, 20 volts, 0. Wah, wah, wah. Okay, so that was a good PMIC, so I will write what board it came off of and keep it in my drawer. There's gotta be something more wrong with this. This may go beyond being able to do on stream. I'm probably gonna have to pore over this for a while on my desk. Gee, I wish I brought an easier one than this. Okay, so initial problem was an exploded SMC. And now we don't have PP5VX enable. I would like to check the CPU. Let's take this heatsink off. And I may have done all of this work on something that has an exploded CPU. No, the CPU's physically okay. Okay, there still might be a chance for this. CPU's physically okay, it didn't pop. Welcome to the Paul Q. Sorry about the anticlimactic finish here, but yeah, I'm going to have to spend some time on this one. This one's not going to be streamable, finished on stream. But Dan will be back in, yeah, probably right after me. He might just start this stream right now. I'll go see if he's ready. We might just continue this right through. Let me put some stuff away. I'll clean up my session here, and Dan may come in and just start right away. Well, thanks for tuning in, guys. Keep that good PMIC around. Is Dan ready?
I don't know.
We have our stream assistant here. Hi. Sure. We could have an interlude of cat cam. There's a Mr. Clinton.
And there's a berry.
And there's a berry. Live from the floor of Rossman Repair Group is a Blackberry the cat, sitting right next to my desk. I love that cat. Blackberry's best cat. Mr. Clinton's loudest cat. Blackberry's best cat. Oh, we'll also have Oreo say hi. Oreo's right here in the studio. He can say hi. Come here, little Oreo. Say hi to the people. Say hi to all your adoring fans.
No, crusty.
Well, Dan will be back in probably about 10 minutes or so. We'll have another live stream. Nice seeing y'all. I'll wind up looking through the chat later. I'm terrible at reading chat during the stream, so that, yeah. I'm terrible at reading chat during stream, so I'll read chat later. Any comments that you have on the stream, I respond to usually. I'll keep an eye on things. Yeah, nice hanging out with y'all.